We're going to finish 2.5 with this video, and that's the end of chapter 2 other than the practice test. I'm going to do the handful of even problems that I have. I'll flash your odd problems up on the screen, but I'm not going to work your odd problems. You might be able to do this now. If you can do this now, don't watch me do number 2. They're very similar problems. So in problem 2, I give you a cost function for producing X units of a generic product. Just wants me to find C, the cost function evaluated at 4 for part A. So I'm going to go 0.4 times 4 squared plus 7 times 4 plus 8 for plugging in 4 for the cost function. And then clear this out, 0.4 times 4 squared plus 7 times 4 plus 8. I get 42.40, and that is going to represent dollars, but the answer to part A is just 42.4. This C represents the total cost of producing 4 units of the object. So for my answer to part A, it's just C of 4 is 42.4. To interpret my answer, I already typed it up here. The cost, because this is a cost function, it's the total cost to produce 4 units is $42.40, but about 10 bucks or 11 bucks each. Now I'm going to create the marginal cost function by taking the derivative of the cost function. So I'm going to write marginal cost function, C prime of x, take the exponent 2, multiply it by the coefficient 0.4, lower the exponent by 1. The derivative of 7x is 7. The derivative of the constant 8 is 0. So the marginal cost function, I just need to multiply this 2 times 0.4 and get 0.8 times x plus 7. That's the answer to part C. That's the marginal cost function. Part D just wants me to plug 4 in for the x. 4 stands for 4 units, but the marginal cost function is actually going to give me the cost associated with the 5th unit. So I just plugged in 4, and now I'm just going to do 0.8 times 4 plus 7 and get 10.2. So the answer to part D, C prime evaluated at 4, the marginal cost function evaluated at 4 is 10.20. Now I need to interpret. Plugging a number into the cost function gets the total cost for that many units. Plugging a number into the marginal cost, or the derivative of the cost function, gets the cost for 1 more unit, and that's going to be the cost of producing the 5th unit. So the cost to produce the 5th unit will be $10.20. I wrote 11 down here. I probably cut and pasted from another answer and didn't change it properly. 3 just has an ugly derivative. It's not particularly ugly, but it's the same question. I give you a generic cost function to produce cell phone cases. I made up a product as opposed to just making it a generic product. I'm going to run through the same questions with a slightly more complicated derivative, but not that hard. Now I'm going to do my problem 4, which is your problem with just different function. So first, this is my cost function to make X pairs of socks. What is C of 50? C of 50 is the total cost to make 50 pairs of socks, and it's going to be the natural log of 50 plus 0.75 times 50. And this is a completely contrived function. I made it up just so we could do a derivative that's more interesting. So natural log of 50 plus 0.75 times 50. And I get, round into 2 decimals, $41.41. So my answer to part A is C of 50, rounded to 2 decimals, is 41.41. Now let me interpret that. Well, this C represents the total cost to produce 50 items, in this case 50 pairs of socks. So I wrote the total cost to make 50 pairs of socks is $41.41. That's my answer to part B. Now I'm going to create the marginal cost function. I need to take the derivative of the ln of x, which is a little bit harder. So the marginal cost function is going to have 2 components. One component is the derivative of 0.75x. Since that's a first power term, it's just 0.75. But I also need to do the derivative of the ln of x. And how do I do that? I create a fraction, and in the numerator of that fraction, I write the derivative of what's in the parentheses, and the denominator of the fraction, I write what's in the parentheses. So it's the derivative of x over x. The derivative of x is just 1. It's a first power term, so its derivative is just its coefficient of 1, and the denominator stays x. That's the derivative of ln of x. This is going to be the derivative of my margin. This is my marginal cost function. It's 1 over x plus 0.75. I did the derivative of the natural log of x by taking the derivative of x, putting it in the numerator of the fraction, and putting the argument x in the denominator of the fraction. The derivative of x, because it's the first power term, is its coefficient. It has an implied coefficient of 1. Now I'm going to evaluate the marginal cost function at 50. I'm going to do marginal cost of 50 units is 1 over 50 plus 0.75, and I'm going to round to 2 decimals again. So fraction 1 divided by 50 plus 0.75, and I get 0.77. I didn't even need to round to 2 decimals. My answer to part D, the marginal cost to produce 50 pairs of socks is $0.77, which is the same as 77 cents. Now interpret my answer. Plugging a number into the marginal function gives the next. So in this case, the marginal cost function's going to give the cost to make the next pair of socks. The next pair of socks is going to be the 51st pair of socks. It's going to cost $0.77, which is the same as 77 cents, to produce the 51st pair of socks. So plugging numbers into the cost function gives the total cost to produce so many units. Plugging values into the derivative of the cost function, or the marginal cost function, gives the cost to produce the next amount. Let's do 5 together, and I'll skip 6. 5 and 6 are twins. Maybe we can do these together. So, boy, my dad was into bobbleheads when I wrote this problem. I have so many bobbleheads that I don't know what I'm ever going to do with them, but nevertheless, it was important to my dad to get them for me, so I'm happy to have them. So this function, Bob's Bobblehead Company, determines the profit by producing and selling a certain bobblehead can be modeled by this function. The profit to sell X bobbleheads is given by this function, and this little part right here says this only works making between 0 and 7,000 bobbleheads. Maybe after the production gears up over 7,000, maybe they don't have the capacity. Maybe they have to open up a new store, or maybe they've got to pay so much overtime that this function's not going to apply anymore. So this is a profit function, but it only works for up to 7,000 units. After 7,000 units, the profit function isn't applicable. That has nothing to do with this problem. It's just common to see that in problems when you're given a function that's a realistic function, to have some quantifier on it that it's not going to work for every number in the world. It only works for a certain band of numbers. So X is the number of bobbleheads. Big P of X is the profit. Let me do part A. To do part A, I'm just going to take 1,000 and plug it in for the X's. I'm going to get negative 0.001 times 1,000 squared plus 8 times 1,000 minus 1,000. I could choke on this pretty quickly, so if I type something in wrong, I'm sorry. So if my answer is wrong, this is just my inability to press buttons. Oh, I should be minus 1,000. I just did plus 1,000. I almost self-fulfilled my prophecy there. Assuming I didn't make a mistake, my answer to part A is the profit from making and selling 1,000 bobbleheads is $6,000. So now I'm going to do the interpret part for part B. So the profit, and this company produces and sells the bobbleheads. So I'm going to say from producing and selling. So they produce and sell. From producing and selling. The number in the parentheses is the number of bobbleheads. And the number to the right of the equal sign is the profit. Now I'm going to do a derivative to create the marginal profit function. To do the derivative, I look at the original function. It's just a generic general power rule. I'm going to take the first term, multiply the exponent of 2 times the coefficient of negative 0.01, lower the exponent down to x. The derivative of 8x is just going to be 8. The derivative of the minus 1,000 is going to be 0. So my marginal profit function, which is the derivative of the profit function, when I multiply this, if I do it right, it's negative 0.002 x plus 8. Done with part C. Moving on to part D, I'm going to find p prime of 1,000 by just going negative 0.002 times 1,000 plus 8. So negative 0.002 times 1,000 plus 8, and I get 6. So the answer to part D, the marginal profit function evaluated at 1,000, gives me the number 6. And marginal means next. The profit from selling the next or the thousandth and first unit is going to be $6. That's what I'm going to do for part E. So the additional profit, and my grammar is wretched, so you can do better than me, that would be great. The additional profit from producing and selling the 1,001st bobblehead, I'm just going to say from the 1,001st bobblehead, is $6. So the total profit was $6,000 from selling and producing 1,000. It's going to go up to $6,006 when you sell and produce 1,001. So I'm going to get an extra $6 in profit from that thousandth and first. So always for marginal, you have to increment by 1 the number in the parentheses. I'm going to do 8, which is a lot like problem 7. Doing okay on time here, I guess. Yeah, definitely. So our problems look real similar in that they have a square root in the derivative. Again, I'm just trying to make the derivatives a little bit of interesting. So completely just made up this problem. Actually, it probably had a function that I used before, and then these problems got kind of stale in terms of the words I used. I think this was like selling newspaper subscriptions back in the day, and nobody has a newspaper subscription anymore. I used to, but up until about 8 years ago, and heck, I was a paper boy, so I like reading the paper. I just don't subscribe anymore because of the internet. Anyways, this profit function is the amount of profit the company will earn in a day by selling X subscriptions of whatever they're selling through telemarketing. So first I'm asked to find P of 16. P of 16 I'm going to get by plugging 16 into the profit function. No reason to do that by hand. I'm going to do 15 times 16 plus the second square root of 16. And I get 244 for my, whoa, down here I have 236 written. I wonder, I must have a wrong answer there, because this looks right. 15 times 16 plus second square root of 16 is 244. It's a mistake here. There's got to be my work has to be littered with mistakes. I'm not particularly accurate in my work, even when I take time. So the answer to part A is P of 16 is 244. What does that mean? Part B wants me to interpret. Well, the 16 stands for 16 subscriptions. The P stands for the profit. So the daily profit from selling 16 subscriptions will be $244. I can't write better than what I've typed there. So the daily profit, I probably should say, because this is doing daily profit. The daily profit from selling 16 subscriptions is $244. Again, hardly maybe worth having a company for $244 profit. For an individual person, fine. Company, maybe not so fine. Now I'm going to create the marginal profit function. And to do that, I need to rewrite the profit function with a fraction exponent. So that square root, I need to turn the square root into a 1/2 power, because the square root of x is really shorthand for the second root of x to the first. So when I go to take the derivative, I have to get the radical written with a fraction exponent. Now I can create the marginal profit function by doing my derivative. The derivative of 15x is just 15. And then for the next derivative, I'm going to take the exponent, multiply it by the implied coefficient of 1, and lower the exponent by 1. And when I lower the exponent by 1, I do it as 2/2. So the marginal profit function is 15 plus 1/2 times x to the negative 1/2 power, because 1/2 minus 2/2 is negative 1/2. I'm going to make that negative exponent positive by burying it in the denominator of the fraction next to the 2. And then I'm going to make the fraction of 1/2 as an exponent back into a square root. 1/2 exponents are always square roots. And this is a pretty non-pleasant marginal profit function. And there's what I have there, other than I have a minus sign. My answer is, this is what happened. I probably had a minus sign there and I changed it to plus. And that's why these answers were wrong, because I changed the sign and I didn't follow up. Which means probably these are wrong too. So let me fix these numbers. But anyways, this is the answer to part C. The marginal profit function is 15 plus 1 over 2 times the square root of x. Now, let's evaluate the marginal profit function at 16. The marginal profit function evaluated at 16 is going to be 15 plus 1 over 2 times the square root of 16. No need to do that by hand. So 15 plus 1 divided by, and then 2 times square root of 16. On my calculator, I better put the whole denominator in a parentheses. Otherwise, I might get something wrong. It's going to be 1 over 8, because the square root of 16 is 4, and 2 times 4 is 8. Let me make sure 15 plus 1 over 8 is the same, and it is. Should round to 2 decimals, so I'm going to do 15.12 for my answer to part D. So the marginal profit for selling 16 subscriptions in a day is $15.12. Now let me say what this means. An additional $15.12 of profits will be earned by selling the next subscription during that day. The next subscription after the 16th subscription is the 17th subscription. So this is a good sentence that describes what the marginal profit function gives me. It gives me the profit from selling 1 more unit. So your problem 7 is remarkably like this. We just have 1 more problem each to do, 9 and 10. And my nephew, who is 18 now, used to be a Boy Scout. Actually, he's pretty close to being an Eagle Scout. I don't think he quite made it. But anyways, Pinewood Derby was a big thing in his life when I wrote these when he was really young. And this problem kind of lived on, and it's okay. Your problem 9, my parents live in Sun City, and my mother used to garden. Now she's in her 80s. She doesn't garden so much anymore. Anyways, and you can't grow blueberries in Sun City, I don't think. Anyways, this is your problem. My problem is going to be essentially the same. I give you a price-demand function. So a Boy Scout group builds Pinewood Derby cars. Apparently they sell them. And they found the price-demand function is this. Meaning, if they want to sell X cars, this is the price they need to charge. Let me figure out what the price-demand function is at 10. So I'm going to do price-demand, lowercase p as opposed to uppercase p. 10 stands for 10 Pinewood Derby cars. And these numbers may not be that realistic. I have no idea what a Pinewood Derby car would sell for. You don't really sell them, you make them. They made the episode of The Simpsons, if you guys, South Park. They did a Pinewood Derby car. Anyways, it says 20 bucks. If I can't see my calculator, the glare's funky right now. It has to do with the lighting. But the answer to part A for me is P of 10. The price, if I want to sell 10 Pinewood Derby cars, is 20 bucks. So the 10 stands for the number of cars. The answer is the number, how much they'd have to each, I'd have to charge for each. So I might say something like this. At a price of 20 bucks per car, and grammar is not my friend, at a price of $20, 10 cars will be sold. Or 10 cars will be sold when the price is $20. Now I'm going to create the revenue function by using price times quantity. Here I have quantity times price, just because it makes the math easier. But the revenue function is just the price demand function times x. The x can go on either side for the multiplication. It's maybe easier to do the multiplication with the x on the left-hand side, but on the right-hand side is fine. So my answer for part C, my revenue to sell x Pinewood Derby cars is going to be negative 0.50 x squared plus 25x. Done with part C. Part D just wants me to plug 10 into the revenue function. Plugging 10 into the revenue function, you get negative 0.50 times 10 squared plus 25 times 10. It's just going to be a number answer. So negative 0.50 times 10 squared plus 25 times 10. My answer is just that number, 200. So my answer to part D is R of 10 equals to 200. And this makes sense because at a price of $20, 10 cars will be sold. 20 times 10 is 200. This says the revenue from selling 10 cars is going to be $200. So for part E, the revenue from selling 10 cars is 200 bucks. Last few parts, find the derivative or the marginal revenue function. To find the marginal revenue function, I take the revenue function, I do its derivative, and it's an easy derivative. So I'm going to go 2 times negative 0.5, and that's going to give me negative 1, x to the first power, and the derivative of this 25x is just 25. So my marginal revenue function, the derivative of the revenue function, is going to be negative 1x, I don't need to write the 1, but I can, plus 25. And then evaluate the marginal revenue function at 10. The marginal revenue function evaluated at 10 is negative 1 times 10 plus 25. My answer is good. That's going to simplify to 15. I can do that in my head without my calculator. And now interpret. This means I'm going to earn an extra $15 by selling the 11th car. By selling the, the 11th car. So an additional $15 of revenue will be earned by selling, so the price has to change to sell the 11 cars by selling the 11th car. And again, if we really dug down into these functions, we'd realize they're not things of beauty, and maybe some of the numbers that come out, if you really tried to focus on them, maybe they would stray from reality a little bit. but I just tried to make the calculus not so disgusting and still, drive home the idea of what marginal profit, marginal cost, and marginal revenue is without maybe trying to, humiliate us with really disgusting algebra. So that's the end of new material for Chapter 2. We just need to get through the practice test, and then we'll move on, take the test, and move on to Chapter 3.